So in this session we will continue our legacy of organic named reaction series. Okay, and today we will discuss uh, uh, the another name reaction that is called Cannizzaro reaction. Okay, this is a very important reaction, right? And now you are seeing on the screen, this is a general scheme of the reaction. Okay, so let me tell you, this is our substrate. This this is our substrate. We have taken 2 mole of this compound, 2 mole of this aldehyde in this substrate, and here our reagent OH minus, that is the base reagent, and this is our product alcohol plus acid. Okay, so this is a general scheme of the reaction. We have taken here substrate aldehyde, and we have taken here reagent base OH minus, and this is our product we get from this reaction, that is acid plus alcohol. So the main important thing you have to keep in the mind, right, how to identify it's a Cannizzaro reaction or not. Okay, so the main simple thing, the main important thing is you have to take a substrate, such substrate, such aldehyde. Aldehyde can be, substrate can be, because here we have taken here aldehyde in the substrate, and that aldehyde can be aromatic aldehyde, or formaldehyde, or another aliphatic aldehyde, another aliphatic aldehyde. But the condition is there should be no alpha H, no any alpha H. Okay, so if the substrate has, if this substrate is an aldehyde and that aldehyde have no alpha H, then we can say, and the reagent we have taken here is a base, then we can say such reactions are called Cannizzaro reaction. Okay, so the first thing is to identify the reaction, whether this reaction is a Cannizzaro or not. Then check the substrate. If the substrate is an aldehyde, that aldehyde can be a aromatic aldehyde or a formaldehyde or any other aliphatic aldehyde, and also the most important condition is that aldehyde should be no alpha H, okay, and we have a base OH minus, then we can say this reaction is a Cannizzaro reaction. Okay, so now let's start the mechanism. So before starting the mechanism, I want to tell you one thing. You can see here, this is our substrate, aldehyde. We have taken here 2 mole of aldehyde, okay, 2 molecule of aldehyde, right, and we are getting the product. This is the acid, carboxylic acid, and we have a alcohol. Now you can observe that this substrate, this aldehyde is oxidizing, oxidized to acid, and this same aldehyde is reduced to alcohol, right? From this general scheme you can also observe this, that this substrate aldehyde is also oxidizing to carboxylic acid, and same substrate, this is also reducing to alcohol. It means here is a reduction and oxidation is occurring in the same molecule. It means it is a Cannizzaro reaction. Cannizzaro reaction is a redox reaction. Because here is oxidation and reduction is also happening. Okay, that's why it is a redox reaction, we can say. Okay, So now let's start the mechanism of this reaction, of this Cannizzaro reaction. So let's take an example. Suppose we have taken here two molecules of aldehyde, such aldehyde that has no alpha H. Okay, there is no alpha H in this aldehyde. Okay, and now we have taken here is a base OH minus, that is NaOH, right? So the main thing is because there is no alpha H in this substrate, no alpha H, right, in this substrate. So if there is no alpha H, because we also know that if there is a alpha H, and that alpha H will be more acidic, and then this OH minus will be work as a base, and then the acid base reaction will be happening in the first. But here in this case we have a no alpha H, so that's why this OH minus will work as a nucleophile at this carbonyl. This OH minus will work as a nucleophile at this carbonyl center. So how the reaction happen? See, RC double bond OH, and then the OH minus, this OH minus is working as a nucleophile, and it will attack on this carbonyl center because this carbonyl is a electron deficient center. Okay. Oh, sorry. Wait. This is the electrophilic center. Okay. This carbonyl C double bond O is a electrophilic center. Electrophilic center. It means why it's electrophilic center? Because you should have to know the proper reason behind every mechanism. Okay. Because there is oxygen and there is a carbon. So on the oxygen there is a delta negative charge, and on the carbon there is a delta positive charge. Okay, because there is a electronegativity difference between this carbon and this oxygen, and that's why this bond will be polarized into delta positive and delta negative. So that's why this carbonyl is working as an electrophilic center. It means that OH minus will attack at this carbonyl center. Okay, so let me show you in more clear. Okay, let me erase all this. Now you have two molecules of aldehyde that has no alpha H, and we have taken here OH minus as a nucleophile, and you all know that this OH minus will work as a nucleophile, and it will attack on this carbonyl center, and when it attack this double bond, this pi bond will shift on the oxygen as a negative charge, and you will get something like this, O minus, and here hydrogen, and here OH. Okay, because we have taken here two molecules of aldehyde in the solution, so we have another molecule also here present outside, and because the negative charge is on the oxygen, and this negative charge wants to get a comeback, and when this negative charge will come back, then this hydride, then this hydrogen will leave as a hydride, and it will attack on this another molecule, another substrate. Okay, and then this bond will be shifted on the oxygen, and then you will get something like this, C double bond O, and here OH, right, here OH plus this molecule RCO minus, and here is a H, and here is a H. Now what happened, because this is an acid, because this is a carboxylic acid, and we have here O minus, so that's why this hydrogen is a more acidic proton, so that's why this O minus, let me erase all this. Then what happened, then this O minus will take proton from this acid, this proton, right, and you will find something like this, RC double bond O minus plus RCOH, and here is a CH2. Now just do the workup. By workup, this carboxylate anion will convert into carboxylic acid. RC double bond OH, and we have here alcohol. So write this RCH2 OH. This is our final product. Okay, this is our final product of this reaction, right? So you are seeing that this is our substrate aldehyde. This is our substrate aldehyde that has no alpha H, okay, and this aldehyde, and now see the product. We have an acid and we have an alcohol also. It means this substrate aldehyde is oxidized to acid, and this substrate is also reduced to alcohol. It means here is a redox reaction is happening here. Redox reaction, Cannizzaro reaction is a redox reaction. Okay, and this is all about the mechanism, how this reaction is happening. Right. So now let's take another example for more clarity, and that example will be more a standard example. Okay. So now let's check another example. Right. Suppose if we have something like this, question number 2, right? We have benzene ring here, another benzene ring also attached to this ring. We have here CHO, aldehyde, that is a no alpha H. This substrate is a aromatic aldehyde, okay? And here we have taken QOH, right? 100 degrees Celsius, temperature condition, 5-minute reaction time. Okay, so now see, we have here aromatic aldehyde, right? Aromatic with no alpha H. This aromatic aldehyde have no alpha H, okay, and we have taken here is a base KOH. It means because there is no alpha H in this aldehyde, so that's why this OH minus will work as a nucleophile and it will attack on this carbonyl. Okay, so see what happened. This OH minus KOH base will work as a nucleophile. It will attack on this carbonyl center because it's a electron deficient center, and then this double bond will shift on the oxygen, and then you will find something like this. We have here OH, right, and here is the hydrogen also, right? So in the question, if you have not written here 2, then you have to assume that in the solution we have a two molecules of this aldehyde will be present. Okay, if there is a written 2, then it's a fine, then it's very good, and if there is not a written 2 here, then you have to assume that in the molecule we have a in the solution we have a 2 mole of this compound. We have 2 molecules of this aromatic aldehyde. Okay, so just the another substrate is waiting in the is waiting outside. C double bond H, and what happened? And because here is a O minus, and this O minus charge will get a comeback, and when it get a comeback, this hydrogen will leave as a hydride and attack at this carbonyl center, and this double bond shift on the oxygen, and then you will find something like this. Here is a carboxylic acid, and plus we have here C O minus, and here CH2, right? And this O minus will take proton from this acid, because this is an acidic proton. O minus will take proton from this acid, from this carboxylic acid, and then this bond will break and it goes on the oxygen as a negative charge. And then after the workup, you will get a final product, something like CH2OH here. Sorry. Here CH2OH, right? And plus you will also get an acid, C double bond OH, and this is our final product. Final product of this reaction, right? So this is this example is a very, very good example, okay, because it's a standard example, okay. So first of all, you have to identify, right, which reaction is this. Is it a Cannizzaro? Is it a aldol? Okay. So how can you identify? Just see the alpha H. If it has alpha H and we have a reagent is a base, then it will be a aldol reaction, okay. And if there is a no alpha H, then this base will work as a nucleophile, and then such mechanism, and then this reaction proceed in this way, okay. And you will get alcohol plus acid also. This is alcohol and this is our acid. This is redox reaction. It means our reactant is a aromatic aldehyde, but we get a product alcohol plus acid. It means this aldehyde is getting oxidized to acid and also is getting reduced to alcohol also. It means it is a redox reaction. And this is all about the Cannizzaro reaction. So if you have to identify whether this reaction is a Cannizzaro or not, just see that aldehyde have a that aldehyde has a alpha H or not. If there is no alpha H, then we can say then the reaction will be Cannizzaro reaction, okay. And if there is alpha H, then we can say this is not a Cannizzaro reaction. This can be another reaction like a aldol condensation, aldol reaction, okay. So this is all about the Cannizzaro reaction. I have explained you by two examples. The last example is a very, very best example, very standard example. I hope you will all understand. And if you have understood very clearly, crystal clear, then please like, share and subscribe this channel for only organic chemistry, okay. Only organic reaction mechanism we will do here on this channel. So tab tak ke liye tata, bye bye, see you soon in the next episode series of organic named reaction series, okay. So thank you for watching my video. Please like, share and subscribe.